So what are we trying to do? Yeah, so we had this in this thing. Oh, yeah. So, but do you see the problem, right? The other terms
Yeah.
need not be divisible by higher power. That is where the problem comes, right? Yeah, there may still be an argument, but it will be messy. So, and that's why when you were giving that argument, I was very focused on that the other terms are divisible by higher power in the earlier case, because that was the key in our argument, which does not seem to work directly now. Yeah, so see if you can rectify it.
If C, like I had assumed that the highest power of like VPN is C and VP x minus y is A. So if C is smaller than A,
Yes.
C is smaller than A, then this is true. Then like the argument can work because
Yes.
x minus y will become p raised to power 2A and
Yes.
which is greater than A plus C. So it divides then.
X minus y square will become 2a.
Yeah, 2A. And this is
Yes.
greater than A plus C.
Yes, yes.
Greater
That
than or equal to. We can add the equal to sign
equal
also.
to sign also, right? Yes, that case works. That I agree with you, right? But the
Yeah.
half of the other cases, and that same argument doesn't symmetrically doesn't work. Like is a so yeah. I understand. Yeah, this case will work because again, in this case, it implies that higher powers divide these terms, and so it will not divide the whole thing. Good. But
Yes,
how do you
sir.
do? So then point is that okay, I mean, if you are not able to do it, then we can try to do something simpler, right? We can try to okay, so basically you have already done this. This case we are done. If VPN is 1,
Okay, yes.
basically from what you have said right now, it's done, right? So at least we have done something. Now we will try to use induction.
Okay.
Maybe, right? So that I think might be useful. Yeah. So now let's say that if VPN is 2, then so we will fix the A forever and try to use induction. Can we prove it for 2? Can you prove it for 2 now? Let us see. Assuming the case for 1. So n is like p square n1.
Yes, sir. It will be A square into NC2 wait, so we know that A plus 1 like wait, can we just do it for once, like one we can do it once
Yes.
for one.
Yeah. So how do you do it?
From there,
So
it will be that
p to the A times A1 and n is p
N.
times n1.
Yeah, okay.
And this is 2a times a1 and right, and let me just write this as nc2.
Okay.
because it's enough to explain. Right. So from here you see it follows, right? Because this is a plus 1. Highest power in this is of p, and this is a plus 1, but in this it is 2a. So it
Yes.
is, or no, or wait, are we incorrect? Yes, it should not even be equal, right? It should be greater.
Yes, son.
But in this case, it's not necessarily greater. If a
Why
is equal to 1,
why?
because a can be equal to 1.
A can be equal to 1, right?
Yeah. If a is equal to 1, then let's see, right? If a is equal to 1, then this becomes p square, n1, a1, this. And then this
Okay.
thing is also p square, a1, this. And then it may happen that p doesn't divide and choose 2. Right. It will
So
not,
how
again,
does that matter?
okay. If it matters, because then you see, then p square divides this and p square also divides this. Then how do we know that p cube will not divide the whole expression?
PQ will not, but we have proved that let's say that even p cube divides the second expression, but it does not divide the the first expression, right? So we have proved that p square divides wait, x raised to power n minus y. So
Yeah, then there is a problem, right? Because see, our argument was what? That p square divides this and p cube doesn't divide this, and p cube divides all the rest. Right? We use the fact that p cube or higher power will divide the rest of the expressions, but it will not divide the last expression, so it will not divide everything. So it will not divide the sum.
yes,
But in this case, we cannot say. In this case, there is a problem, right? Or right, yeah. Basically, the sum, like p
maybe
cube.
like if when we write NC2, we have n into n minus 1 upon 2, right?
Yeah. So I understand that p will divide it. P will divide and choose 2. Yeah, it's true. Yeah, because p divides n, right? So p will divide and choose 2. But it's like a ad hoc
I don't
reasoning.
know whether it will,
I think
because
you're correct. Yeah, because there is a problem when p n equal to 2. Sorry, when p equal to 2.
yeah,
Yeah. So and this is getting ad hoc reasoning also. It's becoming.
it needs to be somewhat like this n should be odd. And if n is odd, then we have the right hand, the n minus 1 and 2 gets cancelled out.
Right.
And that is an integer, and n is also an integer, and p divides n now. Like
Yes.
that's
Yes.
what
And
is
in that
given.
case,
So
that's right.
yeah, but
Yes.
if n is even,
no, yeah, no. The problem I think is in p, because even if n is even, we know that p divides n, right? So p will
yeah,
divide n. Even if n is even, p will still divide n by 2. Right.
if p is even,
If
p
p is
will divide n.
it will
Yeah,
still,
okay.
unless the
Because
problem
only even prime number is this 2.
2. So the 2 is the only issue. 2 is the only problem, right? But again, you see, the method is becoming ad hoc. It's not very, right? It's kind of, then you have to do for p equal to 2 and so on. So the point is that let us roll back a little bit and let us just try to prove this case properly. Okay, that this where vpn is equal to 1. Yeah, let us try to do this case properly. Or let's do one thing. Okay. If you assume this, then can you prove for when vpn equal to 2? Let us see if we can execute the inductive step. Okay, so you assume that we have proved this. We have more or less proved this, right? Unless when p
Yeah,
equal to
sir,
2.
can the previous thing that you had written, can you write it like one more time? The p
Yes,
raised to power in p form.
yes,
Because then we get that, yeah, then over here we get that from this we get that P divides NC2. Like that's what we will get if this is true, right? This is
Yeah,
what we get. And
yeah.
now we write it for 2, and we use this thing that we have got, that P divides NC2 and highest power over here is 2.
Okay, okay.
Like CP of x my x raised to power VPN.
It's 2. You want to do that case?
Yeah, okay.
Okay.
For now we do that case.
So what were you trying to say? You're trying to say we can use this reasoning for the next case. Is that?
Yeah, like
Okay.
the fact we got that P divides N minus NC2. So we
Okay.
can use this for the case, for this case that we are going to do ahead
Okay,
for
okay.
VPN. Yeah. So like one more time we expand it by binomial theorem.
So,
Yeah.
right, okay. So we have this expression, you mean?
Yeah.
Okay. But now, again, now this will become 2. This p square, and this will become p cube.
Yeah. Okay. Over here we get 1 minute. This is yes, son. This p cube divides this, so we need to prove that p raised power 4 divides the second term, second
Right, right,
expression, right?
right. Yeah.
So we already have that it will not be p square. Wait. Okay, it will be p square. Correct. 1 minute. Am I getting confused? It will be p raised to power 4. No. Yeah, it will be p raised to power 4. The thing, yeah, the thing that you have written, it should be p raised to power 4 over there, I think.
Here.
Yeah.
Okay. No. Wait. Something is going wrong. Wait. Okay, sorry. So the problem is that we were looking at this when a is equal to 1.
Yeah, now we need to put a equals to 2.
No, we are doing this VPN equal to 2. The a we are not changing.
Oh, so
Yeah.
yeah, okay. A, then
So
where is A in the
so
first
a
one
is
here?
equal to 1. So this a,
Okay.
right? So that a is equal to 1, and now we are doing that case. But the VPN is equal to 2. Yeah. But you
Okay.
see,
So
it doesn't work. It doesn't work, right? Because see, you cannot say that p to the power 4 divides this. Because see, last time we somehow said that p divides n choose 2. But now you need to say that p cube divides n choose 2. Or p square divides n choose 2, right?
1 minute, son. This thing we have p raised to power 3. Like we are doing it for a is equal to 1
Is
right
equal to
now, right?
1, right? And we want to show
Okay.
that p to the power 4 divides this. And it's not so clear because this comes down to p square divides n choose 2.
Yes, son.
Right? So that is
Uh,
the problem, right?
yes, son.
Yeah, like last time we somehow could say that p divides n choose 2, fine. But now p square divides n choose 2 is not, or is it clear? If it's clear, then it's done. Because this is what we need to show. Is it clear that p square will divide n choose 2?
No.
Yeah, but I think, okay, let's just think about this and see. So first be clear, right, that we are doing the case when a is equal to 1. So that's clear. And we are doing this VPN equal to 2. So see if you can think something. But p square divides n, so you can use that.
P square divides N.
Yeah.
How do we get that?
No, oh, that is our assumption.
Oh, okay, okay. Yes, sorry.
You can use that.
And first we had also got that P divides NC2,
Hmm.
like by our induction hypothesis.
That's right. Yeah. So it does work, right? Other than when maybe P equal to 2. So P square will divide N. Right? So we know that P square divides N, right? So P square will divide N by 2 also. Unless if P is equal to 2.
Yes,
So
sir.
same
N
reasoning.
by 2 and N, if N is odd, then
If N is odd, then P square will certainly divide N. Because then N by 2 will
okay.
not come in the picture. Then it will be taken care of by this.
Oh,
N
yes,
minus.
sir. Yes, sir. Yes, sir. Then we are done. Then
So
I think
this
that this is correct.
same situation, same thing works. Okay, so then let us finally say what we have said so far. Okay, so basically
The only thing now we'll do, except of one A equals to 1, we'll just substitute A, and I think we are done with this.
same thing will work, right? Exactly.
Yeah.
The only problem is that N equal to P equal to 2. P equal to 2. That case is we are not able to yet do. Right? Is that
Yes.
P equal to 2 is a problem, right? Because if P is equal to 2, then how do you say these things? Yeah, right? Because then this is, because then, yeah, in that case, we had a problem, right? We saw that basically that 4 does not divide 4 choose 2. Or rather 2 square, 2 square. So I wanted to say that, okay, 2 square, yeah. Right. So basically P equal to 2, right? And at P equal to 2, then 2 square divides 4. 2 square is equal to 4, but 2 square doesn't divide 4 choose 2. So the case of P equal to 2 is still a problem. Other than that, we are mostly able to do this in this way. Right? Okay. So
Yes.
yeah, so then let me just clearly state what we have shown. Okay, so basically P divides X minus Y. P does not divide X and does not divide Y. Then we have shown that, but this hypothesis again is very necessary. We have said that repeatedly.
Yes.
And yeah, then basically we have shown that this thing. And see, the point is that because we are using our own method kind of, so we are getting stuck in the P equal to 2 case. Okay, the book method will
Yes.
pass in all the cases. So that's the only difference. Okay, so P not equal to 2 was our thing. But it's good that even with our own method, we are able to do this much.
Yes, sir.
Yeah. But then let us see the book method, okay, so that we can just quickly do this and learn the new tools also. Yeah, or maybe how about this, right? We can leave the P equal to 2 case as a challenge for you if you want to try it, right?
Okay,
Yeah,
I'll do first.
yeah. Try to do this on your own and let's see if you can do it. Okay, and then we can,
Yes, sir.
right? Yeah, and obviously there is this PDF which I did not use so far, but yeah, this is the. So I'll just mail it to you now. Okay, lifting the exponent lemma. Okay,
Okay.
so this is by this person, Amir Hussain. You may have heard his name. He's a,
Yes, yes.
yes, yeah, very
I
prolific
I have few books also of him.
of him. So he's a very prolific, obviously, in Olympiad maths. And so he has this quite old PDF, more than a decade old now. and you can read the theory if you want to, okay. But always you see this p equal to 2 case always creates a little bit of a problem. You see,
Okay.
even
Yes,
here
sir.
they also are facing some things, but we are not going into all the technical details. You see, I think the result is not true for p equal to 2. I think that's what they are saying, okay. But anyways, okay, you can look at the theory, that's up to you. But I will set what I will ask you to mandatorily do is at least do these problems, okay. So not all
Okay.
these are not trivial questions, okay. So my suggestion, the way I tell people to do is that you try the first 5 questions only, okay. The mandatory thing is you try the first 5 questions, but you make sure that you spend at least 2 hours doing this, because see, these are Olympiad questions, so it may take you 30 minutes to do a problem also, but that is not a problem, okay. My suggestion is that if you can spend more time on small number of questions is also fine, okay. It's not a problem, okay. If you get completely stuck, then you can leave it and move forward, okay. But you should spend more time on less number of problems, and then if you have more time, then obviously there are a lot of questions, so it's probably difficult to complete, okay. A lot of questions are there, okay. So you can do, but I will suggest that at least first 5 you should do with spending a lot of time on it, okay. So
Okay.
yeah, and obviously if you are keen, you can read these proofs and this theory also, okay. We have proved most of the result, but okay. All right then, so we will see you tomorrow 7:30, okay.
Yes,
I may not discuss this thing tomorrow, okay. Because
okay.
I may discuss that polynomial thing, okay, because I want to give more time on this to try, and then we can take it up next week. We'll see, okay. But tomorrow maybe the theme can be on the polynomial thing that we were doing last day,
Okay,
okay.
sir. Okay, sir.
Yeah, and you try this, and
Yes.
yeah, if you're okay, we will
Sir,
see you tomorrow.
I
Huh?
okay, sir. I wanted to ask you one thing.
Mm-hmm.
That MTRP,
Huh, yes.
right? That exam is there.
Yes, yeah.
Uh, so I'm thinking to give it this year.
You should give, yes.
So
Yeah.
yeah. So can you give me any tips on how should and what should I do? Or
Yeah. So see, these kind of exams, you have to just try to solve the past year papers. Okay.
okay,
As much
but
as
there are
possible.
only 3-4 past year papers
Yes,
given.
3-4 past year papers. And then what you can do is you can solve. So similar exam is NMTC, right? Have you heard of
Okay,
it? Yeah, and NMTC. So obviously not the first level is just MCQ, and so it's very, very easy. But the next levels, but you can look at the MCQ also. NMTC is a similar exam, and I don't know how much IOQM is useful, but and STEMs, CMI STEMs, right? You can look at that exam also, and these are similar exams. Okay, so because
okay,
STEMs is also question paper made by students, and MTRP is also similar. Okay, stems may be
okay,
slightly more difficult, so you can try these papers. I think this is, in fact, in the last Sunday's class we were discussing MTRP questions, uh, with my other student. He was going to write MTRP, okay. So
okay,
I even had posted one video, some MTRP problems were there. But you solve the papers, and then we can these papers, okay. Stems, NMTC, MTRP, these are relevant, and IOQM is there, but these 3 are relevant, okay. Other than that, there is nothing specific. Yeah. Okay, it's organized by ISI only, Indian Statistical Institute. So it's a part of the fest. Yeah, yeah. Okay.
yes,
So yeah, register for it if you have not. Yeah. In fact, yesterday I sent a mail to my other students about the exam. I somehow forgot because you are new. So yeah, forgot to send it, but you already know about it. So that's fine. Yeah.
yes, sir.
Okay.
Okay, sir.
Okay. Then we'll see you tomorrow 7:30. Yeah.
Yes, sir.
Okay.
Okay, sir.
Okay.
Bye, bye, sir. Thank you.
Thank you.
Bye, sir.